In this video, we're going to go over some of the last problems in the worksheet. These were problems 38 through 43. I also want to go over some of the factoring. They were polynomial equations that you solved using the factoring method. I'm going to do these 6 first, 38 through 43. Then I'll do some of those factoring ones. I chose to do these first because it's a new concept. So I just want to make sure that I explain all of this thoroughly before we get to some of those polynomial equation questions, since we've already gone through some of those. All right, but this is kind of a new concept. So what we want to do here is we want to apply, and by the way, I am looking at question 38. Let me see if, I don't know if you can see that. Yeah, okay. This might not be clear, hold on. I think that's, okay, that's easier to see. All right, so for question 38, we're asked to apply the following operation. F minus g of x. Now, right away when you're looking at this, the notation might seem arcane. We're not distributing this x. A lot of students, when they first see this, think that these parentheses here, it means multiplication. You know, normally you would think, oh, you're going to distribute. Be very careful. This is saying f of x minus g of x. Okay? So we're subtracting two functions that are of x. Another way of writing this, and I think this is an easier way, is literally just f of x minus g of x. This is exactly what this is trying to say. It's saying the same thing. Just this looks a little, I don't know, more esoteric than this, right? Once you see it like this, and you can probably easily figure out what we're trying to do here. So at the top in the instructions, it actually defines f of x, g of x, and h of x. They're all defined there. So let's go ahead and do our first operation, which is f of x minus g of x. F of x is x squared plus 4x minus 12 minus, and then whenever you're subtracting functions, it's always helpful to put some parentheses here, and especially when you have obviously the minus sign, because you want to make sure that you distribute that negative, especially when you have polynomials here. If it's a monomial, it's not going to cost you anything, but if you have polynomials, you got to be careful because you might subtract incorrectly, right? So I put the open parentheses here, and then now I have to write g of x, which is 5x squared minus 2. Okay. So the first thing I'm going to do here is, like I was previously discussing, we're going to distribute this negative sign here. So I can copy this again, x squared plus 4x minus 12 minus 5x squared plus 2. You see, all I did is distributed the negative sign. All right. So now I'm going to go ahead and combine like terms. I can underline this using a red pen to kind of indicate where the like terms are. So for example, x squared and negative 5x squared, we can combine them. So here we're just using our regular operations, so that would be negative 4x squared. And then our 4x doesn't have any partner to combine with, so he just stays 4x. And then negative 12 and 2, they combine and you get negative 10. So then this is our solution right here. Okay, so this is our final answer. Now you have to be careful because it says in the instructions to indicate any restrictions in the domain. So we only have restrictions in the domain when we divide functions. If these are plain old functions without fancy, like, you know, square root or anything like logarithms, you haven't learned those yet. So we're not going to be talking about restrictions that come out from those functions. You will learn them later in the class. But the functions that we're given here are all just plain old, you have a linear function and two quadratic functions. And we already know that the domain for linear functions and quadratic functions is going to be all real numbers. So the only time when you might get a restriction is when you divide them. And we're going to work on one of those. I believe it's question 40. Yeah, we're going to work on that. So that was 38. Now let's do 39. So in question 39, let me adjust this. I feel like it's not clear. Okay. In question 39, it says h, I believe that's a multiplication sign. Yeah. Looks like this. H times g, whoops, that's supposed to be a close parenthesis, of x. All right. So this is very similar to the notation here, right? We're just subtracting two functions. Here, we're multiplying two functions. Remember, this doesn't mean like distribute the x or anything like that. All this simply means, and I'm going to rewrite it so you can see what it means. All we're doing is we're taking the function h of x and we're multiplying it by the function g of x. That's all we're doing. So we can go ahead and locate, okay, h of x is x plus 7, and I do have to write my parentheses because I want to make sure I don't make any silly mistakes. We're going to be probably using the FOIL method or some kind of distribution. So that's h of x, and g of x is 5x squared minus 2. So we're going to do the FOIL, right? So x times 5x yields 5x cubed. Whoops, that's a 3. And then x times negative 2 is negative 2x. 7 times 5x is plus 35x squared, and then 7 times negative 2 is negative 14. Okay, so we got that. Now we're just going to combine like terms. So we have 5x cubed, and then plus 35x squared, and then we have minus 2x, and then minus 14. So the funny thing here is nothing, you couldn't combine any terms. I just kind of rewrote this in standard form where you have the leading exponent ahead of the other ones. You have x cubed and then x squared, and you're just kind of going down, you know, in order. And then that's it. There's nothing else we can do here. So we box in our answer. Okay. That was 39. So let's go ahead and do number 40. So now we do have division here. So you got to be careful. So the notation, it's written like this. So you have h divided by g of x. Okay. Once again, this doesn't mean distribution or anything like that. All this means is we're dividing the function h of x by the function g of x. So just to kind of rewrite this in, you know, more amicable notation, we can just do this. Okay, so we have a fraction bar. We're going to put h of x on the top, g of x on the bottom. Let's go ahead and plug in our functions. This we get from the little section in the instructions, right? So h of x we said is x plus 7 over g of x is 5x squared minus 1. Okay. So we have to be extremely careful when we do this. There are some things that can go wrong. The first thing that I'm going to do is I want to look at the denominator here. Remember from elementary school math, you can never divide a number by 0. That's a math rule here. This is undefined. You might be wondering at kind of more of the philosophical reason behind this. Like why is it that you can't do that? Well, let's discuss that real quick. If you had some number, let's say 10, and you're going to divide it by some other number, let's say 5, what you're trying to say is how many times can 5 fit into 10? That's what division is about, right? So in this case, we would fit 5 into 10 2 times, so that would just be 2, right? Over here, the question is, how many times can 0 go into 5? Well, we know it can go into once, right? And then again, 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 and then again. And it seems endless, right? It seems like we can keep putting 0 and we'll never get there. An analogous question would be like, how many nothings can I fit inside a box? Right? Well, I put one nothing in there and it hasn't taken up space, right? I put another nothing in there. Oh, look, it hasn't taken up any space. So I can keep fitting an infinite amount of nothings. Okay, so in a certain sense, and it's this is very, you know, it's unconventional, but we would say that 5 over 0 is in a certain sense infinity, even though that's not entirely correct. But just to kind of simplify it, so we say it's undefined. Okay, so infinity is not a number, so that's why when you have a number, some number divided by 0, we say it's undefined. Okay, we don't want that. We don't like that. So using this idea, if you have two functions and you're dividing them, the denominator cannot be 0. If the denominator is 0, then we have something that's undefined, just like what I was showing you over here. So we need to solve the denominator to find the x values that make it 0 and exclude that from the domain. So it's only when you're dividing these functions that things get a little interesting here. We need to make a little equation with a denominator. So I'll write it right here, 5x squared minus 1 equals 0. Again, I'm just finding the x values that make the denominator 0. So I just solved this, so plus 1, that's 5x squared is equal to 1, divided by 5, so I get x squared is equal to 1/5. Then I just take the square root, and I get x is equal to positive or negative, right, plus or minus 1 over root 5. If you want to rationalize that, you can write this as plus or minus multiply by root 5 over root 5. Okay, and then that would give us root 5 on the top, 5 on the bottom. That's because some teachers don't like to have irrational numbers in the denominator of fractions. So we found our x value here. And also by looking at this, there's nothing we can simplify. So we can't like cancel anything out. So the answer would just be that, literally, right? X plus 7 over 5x squared minus 1. And then we would have to write our exclusion, right? So in our domain, you can write it with set builder notation. You can ask, it doesn't say in the instructions what kind of notation to use. So I'll go ahead and use set builder notation. So we can say domain, and I can put a little equal sign, and then I put the set builder. So we can say, these are called braces, right? You put that, and then you can say x is an element of the set of real numbers. Some teachers are sloppy and they don't even write that. They just put an x. And then you can put a vertical bar, which means such that. So you're saying x is any real number such that it's not equal to 5, what was it? Root 5. You can put plus or minus here. Yeah, root, because it was plus or minus. Root 5 over 5, and then you can close it. And that would be your restrictions, right? So if you write it in terms of the domain, because it's saying restrictions in the domain. So this is kind of the proper way of writing it. Your teacher might be, like I said, a little sloppier, and she just might say, oh, look, x is not equal to plus or minus root 5 over 5. Teacher might go straight to that and skip all of this stuff, but I'm just giving you the kind of the correct way of writing it. But don't freak out if you go to class and the teacher just writes this, right? They'll be like, oh my God, it's wrong or something like that. No. It's just, this is a more formal way. The teacher might want you to write it like that. So it doesn't specify. It should, but it doesn't specify in the instructions how to restrict the domain, right? So you can confirm this, right, with the instructor. Oh, but I just gave you kind of both versions of it. Okay. And by the way, like I said, even with this set builder, the teachers can be a little bit, what's the word I'm looking, a little loose with the notation. Sometimes they won't write this part. Sometimes they will, but they'll put it in the back. It's just kind of playing around with it. As long as everything's consistent, don't freak out too much. You can rewrite this, different ways. But for your class, one of these two would be good. All right. I don't like the one at the bottom here. I'm vexed by it because it just says what x isn't, but it doesn't say what x could be, right? And of course, the hidden assumption here is real numbers, but we don't like that in math. Anyway, That was 40, so now we can jump to 41. Now 41, things get even more interesting because we're introduced to a new operation for functions. This is called the composition operation. So it kind of, don't confuse this. I've had a lot of students think that this little circle means like multiplication. No, it doesn't. This means composed. That's how you read that. You say G composed with H. Another way of saying that is G of H. Okay, I'm going to rewrite this. You know how I've been rewriting all of these notations, right? We can rewrite this like this. You can say G and then parentheses H of X like that. So what you're doing is you're taking the H function and you're plugging it into the X value of the G function. Okay. So this one's going to be a little bit trickier. So you have to be very careful. You're going to take the whatever your H function is, and you're going to plug that into every X of the G function. So let's look at what this might be. So where is our G function? Let's go to our instructions. It says G is 5x squared minus 2, and it's saying H is x plus 7. So if you're looking at the G function, we have 5, and then instead of putting x, I'm putting open parentheses, because here I need to plug the H function in here. So maybe I'll put like H of x, because we're plugging in the H function. So I'm putting parentheses, squared minus 2. So this is the skeleton, right? The G function is 5 times x squared minus 2, but we're not writing an x here. Like just a plain old x, we're not doing that. We're writing the H function. And I'm going to use red just so that it looks a little bit nicer. Our H function is x plus 7. See how we plug that in to the x value of the G function. All right, so this is just saying, okay, so we have 5x plus, this seems kind of weird. I'm just rewriting the same exact thing, but just without the red pen. Okay, so once we have this, we can go ahead and simplify. And we would have to FOIL this part out first. So that would be 5x plus 7 times x plus 7 and then minus 2. I'll write that down here. So x times x is x squared. So that's right here. X times 7 is 7x. And then we have to do 7 times x, which is another 7x. Add them together, that's 14x. And then finally 7 times 7 is 49. And then minus 2. Now we distribute our 5 to the three things in here. So that's 5x squared plus 5 times 14 is what, 56, 70x. And then 5 times 49 would be what? That's 100, 250 minus 5, which is 245. Minus 2, okay. Now we combine like terms, so we get 5x squared plus 70x, and then 245 minus 2 is 243. And then you'd be finished here. Notice we don't have to worry about all that domain stuff because we're not operating with this division where we have to kind of be concerned with, oh, we're going to get something undefined, right? Like a fraction with an x in the denominator or an x term in the denominator. So we don't have to worry about that here. That doesn't mean you never have to worry about it when you have composition of functions. It just means that here we don't have any fractions or anything like that with an x in the denominator. So we're safe, we don't have to worry about that. So that was 41. Now we'll do 42. 42 says to evaluate each function using the same information. So we know we have g plus h of negative 4. This time, g plus h, this time, instead of just an x, we're given a specific value to plug in for x. So let's go ahead and write this out. So this is the same thing as saying g of negative 4 plus h of negative 4. Okay, now we can plug that in to our g function and our h function. So where's the g function? So that's right here, 5 times parentheses negative 4 squared minus 2. We're just plugging in negative 4 in for x. So that's our g function, and then we have to do that with the h function, so plus, and then that's just negative 4 plus 7. Once again, I'm just plugging in negative 4 for every instance of x that we have. So simplify. Negative 4 squared is 16, and 16 times 5 is, what is that, 50? 80, yeah. So you get 80, and then minus 2 plus negative 4 plus 7. You can just type all that into the calculator. 80 minus 2 is 78, and 78 minus 4 is 74. And then 74 plus 7 would be 81. So we get 81 right here. Okay, and then the last one here is 43. For this part of the picture of the homework stuff. So this has h of f of 2. Be careful with that composition notation right here. This means composition of functions. So to do this, remember, this means h of f of 2. So we need to first figure out what in the world is f of 2, get that number, and plug it into the x value of the h function. So first let's figure out what is f of 2. I'm going to write that on the side. So f of 2, we're going to plug in 2 for our x value in the f function. That's 2 squared plus 4 times 2 minus 12. That is 4, and 4 is 8, minus 12 is negative 4. So be careful here, because negative 4 is the number that we're plugging in to this h function. So now we're saying h of negative 4 is equal to, and we can go ahead and plug negative 4 into the h function. So our h function was just x plus 7, so that's just negative 4 plus 7, which is going to be 3. And then that's your answer. All right? So that takes care of those problems. Now let's look at some of these polynomial questions over here. What was that? 33. All right, so 31, we can look at 31. So question 31 has x to the 4th plus 19x squared minus 20 is equal to 0. So we do get this kind of quadratic trinomial structure. It looks very similar to it, even though it's technically not quadratic because it's got an exponent of 4 with the x. That makes it actually quartic as opposed to quadratic, but we can still use the same techniques to factor it. So remember, here's where you do this x business. You do 1 times negative 20, that's negative 20. And then the middle term, that b, comes down here. Then you have to think of two numbers. When you multiply them together, give you negative 20, and when you add them, give you 19. So you can use negative 1 and positive 20. And since this is a 1 in front, you can go straight to the shortcut, which is to just write the parentheses. You don't have to do the grouping method. You can go straight to the parentheses using these numbers. And of course, if this is starting with x to the 4th, then we have to write x squared because it's x to the square root of x to the 4th is x squared. So we have x squared minus 1, and then over here we have x squared plus 20 equals 0. And we already know that we can use difference of squares formula here. That's x minus 1 times x plus 1 times x squared plus 20 is equal to 0. Now we can go ahead and solve all of these individually. So this one is just x minus 1 equals 0, plus 1 plus 1. So you get x equals 1. Analogously, this will be x equals negative 1. So that's one solution here. That's another one. And then here we have x squared. We could do minus 20 to the other side of the equal sign. So that's x squared equals negative 20. Then you take the square root, take the square root. That's x equals plus or minus the square root of negative 20. Of course, we have a negative inside the square root, so that's going to come out as an I, plus or minus. I'm going to put an I, and the square root of 20 can simplify, because the square root of 20 is just 4 times 5. 4 can hop out as 2, so this turns into x equals plus or minus 2i times the square root of 5, since that's what's left over. And then that would be the next two solutions. So we have one solution here, one solution. These are both real number solutions. Then this is two solutions because it's plus or minus, and these are imaginary because they have an I in it. And in total we have 4 solutions. So that's again just a kind of a logical implication of the fundamental theorem of algebra. The leading exponent's going to tell you how many solutions you have in the field of complex numbers. Okay. So that's for 31. Now we can do 32. 32, it looks kind of blurry on my phone, but I believe it says x to the 5th. Is that minus or an equal sign? Hold on. Oh, I think it's an equal sign. So x to the 5th equals, and then 18x cubed minus 81x. So the first thing I want to do is I want to move these two guys to the left side. Okay, so this is going to be x to the 5th. I have to subtract 18x cubed. So now I have minus 18x cubed. And I have to add, so plus 81x to this side. Plus 81x, and then equals 0. Then I can go ahead and factor. I can pull out an x. That's the greatest common factor of these three guys. So now I have x to the 4th minus 18x squared plus 81 equals 0. Very nice, very nice. So now I can go ahead and try factoring this. This has a quadratic structure to it, just like the previous one we did. So let's go ahead and try factoring that. We can do this x method. So that's 81 on the top, negative 18 on the bottom. Looks like we can do negative 9 times negative 9. So this is going to be x parentheses x squared minus 9 times x squared minus 9 is equal to 0. Again, the number in front of x to the 4th is a 1, which implies that we can go straight to the shortcut and not have to do the whole grouping thing. We can go straight to this. Then, of course, we can go ahead and solve this. So this one is going to simply be x equals 0. This guy, you can factor it again. That's x minus 3 times x plus 3 equals 0. So we get x equals 3, and then also comma x equals negative 3. And then analogously, this is going to be the same. So that's x plus 3 times x minus 3. Okay, so we move them to the other side, negative 3, x equals 3. So look at that, we get 5 solutions here. Of course, one is 0, 2 of them are 3, and the other 2 are both negative 3. So we do get 5 solutions, but 2 of them have multiplicity 2, meaning they come out multiple times. Okay, so that takes care of question 32. And I believe I only have one more picture here. Hold on. That was 31, 32. Okay, now 33 and 34. We're still doing the same thing, right? Yeah, we're doing the same thing. All right, so let's do 33. I'll fit that on this side. So for question 33, we have 3x to the 4th. So minus 14x squared is equal to 5. So we're going to move that 5 to the other side, to the left side. So that's 3x to the 4th minus 14x squared minus 5 is equal to 0. Then we can go ahead and, since this is a trinomial that has that quadratic structure to it, we can go ahead and factor it the way we would normally factor quadratic trinomials, even though, keep in mind, it's not quadratic, it is quartic, because this is an exponent 4. So we do 3 times negative 5, and that's going to be negative 15. And then negative 14 is going to go at the bottom. Then we think of two numbers that when you multiply them together give you negative 15. And when you add them give you negative 14. That so happens to be negative 15 times 1. Okay. So this time we can't use a shortcut because we do have a coefficient here that's not 1. So we'll have to rewrite this using the grouping method. So this copies, you copy it the same. Then you use the new numbers, so it's 15x squared. Remember, they have to have the same letter with exponent of this middle guy. So it's minus 15x squared plus x squared minus 5 equals 0. Then we factor this using the grouping method. So you look at the first two things. You can factor out a 3x squared. And then you're left with x squared minus 5. And then over here, you can you don't factor anything out, so we'll write a 1. When you don't factor anything out, you write a 1 equals 0. Then we can go ahead and put the coefficients into their own parentheses. So that's 3x squared plus 1 times x squared minus 5 is equal to 0. Okay, and then now we can go ahead and solve these two. So this one is going to be 3x squared plus 1 equals 0. So you do minus 1, that's 3x squared is equal to negative 1. Divide by 3, x squared is equal to negative 1/3. Take the square root of both sides, so we get x is equal to plus or minus. Now notice this is the square root of a negative number, so there's going to be an I there. So I, and then it's going to be root 3 over 3. For the sake of time, I just went to quickly simplify that. We've practiced doing this before. So I kind of just skipped the step there. Because this would have been 1 over root 3. So you have to multiply by root 3 over root 3 so you can simplify that. And then on this side, we're going to get x squared. We add 5 to both sides, so that equals 5. Take the square root, x equals plus or minus root 5. So these are the 4 solutions. You got 2 imaginary, and you have 2 real solutions. All right, and then the last one is question 34, and this is a fun one. So this one has 2x cubed plus 7x squared minus 16x minus 56 equals 0. So once you see 4 things, you might want to try factoring out the greatest common factor from the first 2, and then the same for the second 2, and see if you can group it, right? The grouping, use a grouping method. So from the first 2, I can pull out an x squared. So I'm left with 2x plus 7. And from the second 2 guys, the 16 times 3 is 48. So 16 times 4 is 58. No, so it's above. So 16 won't work, but 4, I believe 4 works. Hold on. 4 times, what was it? 4 times 15 is 60. So 4 times 14. Okay, so 4 works. So I can pull out a negative 4, and then now I have 4x plus, what did I say right now? I lost my train of thought. We said 15, 14. Oh, wait a minute. We can pull out more. That's not the biggest one. Sorry. Yeah, so 4 is a bigger 8. I believe. Yeah, 8 works. I should have seen that. So negative 8. And then you have 2x. And then this is just elementary school. Yeah, 8 times. So 8 times 7, right, is 56. So, okay. Equals 0. All right, so now we can go ahead. X squared and negative 8 go in one parenthesis. And then 2x, and I miswrote that, should have been a plus sign. We get 2x plus 7 in the other one equals 0. Okay, so now we can go ahead and solve these individually. So 2x plus 7 equals 0. So we do minus 7. 2x equals negative 7. Divide by 2. X equals negative 7/2. So we got that one. And then on this side, we get x squared minus 8 is equal to 0. So we do plus 8. X squared is equal to 8. Square root both sides. X equals plus or minus. The simplified form for square root of 8, you can break that down into square root of 4 times square root of 2. Square root of 4 comes out as 2. So this is 2 root 2. So we got our 3 solutions. Positive 2 root 2, negative 2 root 2, negative 7/2. This polynomial, its leading degree is 3, which means that we have 3 roots. And that's it. That concludes our video.